Everything is a rectangle. So if you grant me the fact that a triangle is half a rectangle, I'll show you that all these other quadrilaterals that we've learnt about are also rectangles. So let's run through them quickly. Rhombi or rhombuses. Looks like a rhombus, secretly a rectangle. Kites, secretly a rectangle. Parallelogram, very obviously a rectangle in disguise. And a trapezium, again, rectangle in disguise. Now, obviously, I'm exaggerating a bit. Not everything's a rectangle. This pen is not a rectangle, but lots of things when we think about area can be thought of as rectangles. And I think when students hear about this idea of the formula and they see these letters, they don't really know what the letters are associated with. But what I'm going to tell you is all the letters in the formulas for the area of quadrilaterals refer to the side lengths of a of the relevant rectangle. So if we look at the area of a triangle, base times height divided by 2. Well, again, if we recognize that any triangle is half of a rectangle, well, you're just taking the base, the base multiplied by the height of this rectangle and then halving it because it's the triangle is half the area of the rectangle. So base height divided by 2. Same idea over here. If we have a rhombi, the most misunderstood quadrilateral out there, remember rhombi equals side lengths, not necessarily 90-degree angles though. Anyway, X and Y refer to the diagonals of the rhombus. So what you've got here is this. What you'll notice is as it transforms into a rectangle, well, really what you've done is you've halved. You can think about it like this. The height of the rectangle is half of X, so X on 2, and then you multiply by Y. Y doesn't change. So it's half of X times Y because the relevant rectangle has a height and length of X on 2 multiplied by Y. So that's how you get the formula there. Kites, again, same idea. P and Q represent the diagonals of the kite. Again, same idea, right? You're halving one of the dimensions. You're halving this one, say, P, and just Q stays the same. So it's half of P multiplied by Q gives you the area of the relevant rectangle when you transform your kite into a rectangle, right? So a kite is a rectangle in disguise as well. Now, parallelogram. This one's obviously a rectangle, I think. If you take this section here, this sort of triangle here, and shove it over here, you literally just get a rectangle with a base length here and the height being here. So the area of a parallelogram is just the area of a rectangle. So that one's even more straightforward. And finally, this one's a little bit more tricky, but you've got a trapezium. So if we start with our trapezium like this, we've got A, B, and H. You can see that if we, again, we take this sort of triangular part on the left here and then move it up over here, then we can create a rectangle here. And you're probably wondering, where does this formula come from? A plus B on 2. Well, let's think. What is the length of the rectangle? Or what is the sort of this length for this rectangle? Well, I think you would agree if we took this length plus this length, added them together, and then halved it, it's essentially like taking the average of the two lengths. Because that's how you take an average, right? You add numbers together and you halve them. The average of two numbers, you add them together and half them. So essentially, this length here is going to be the average of A and B. And that should make a bit of sense. You sort of take this length here and you add it to there, right? So that gives you the sort of the length of the rectangle, and then obviously the height is the height. So you can also see that a trapezium is just a rectangle in disguise as well. Now, again, not everything is actually a rectangle, but in terms of area, can really help to clarify things, to think of all the areas of these quadrilaterals as being the area of a relevant rectangle. So hopefully that clarifies things, and good luck with everything you're doing.